Hey guys, I know I'm going to run out of time on the notes for today, so I'm just going to work out these notes right here on the sheet so you can refer to them if you are absent or miss the notes for today. Okay, if it says to find the domain, you just pull out what's inside the radical, set it greater than or equal to 0, and then you will just solve it. So adding 5 to both sides, that gives you greater than or equal to 5. If the value under the radical has a negative x, don't forget back in the day when we first learned how to do inequalities, you solve for x the same way, but this right here is not done. You have a negative with the x, so you have to divide both sides by -1, which causes your inequality symbol to flip. So don't forget to flip when you divide it by -1 right here. And so like for this one, it's just 2x greater than or equal to 0. Don't forget it, 0 divided by any number, that is 0. Now, when you have excess information on the outside, ignore everything outside. Even this 3 right here, you're not trying to solve, you're not trying to isolate the square root. You just pull out what's under the radical, set that greater than or equal to 0 and solve. Notice, I did not use this. I don't use that outside. Do not use the 4. Then you just divide by -1 on both sides, and that gets you, oops, I almost forgot. I gotta flip the inequality symbol. So flip, and don't forget, 0 divided by any number is 0. This one here is exactly like the one above that I did. Set it greater than or equal to 0. Move that 4. Man, you are not done here because you've got a negative. Divide by, or negative x. Divide by negative. Don't forget, flip the inequality sign. So again, don't make this harder than it needs to be. Just pull out what's inside the radical, set it greater than or equal to 0, and solve. Okay, so that's it. All right, now, when you go to the graphing part, we got to pay attention to what is here, out here. That tells us if our graph is going to go upward, if it's going to be an upward curve, or if it's going to be a downward curve, it's going like this, and it's decreasing. The y values are decreasing. So when that is x. Now remember, our perfect squares are 0, 1, 4, and 9. So that means those are our x values. So our x values that we're going to put in for this is 0, 1, 4, and 9. And so when you take the square root of those numbers, you get 0, 1, 2, and 3. Okay, because the square root, remember, that's our x was under the radical, but our y is going to go that way. But don't forget that y, or that we had that negative out in front. So that negative, that negative, that negative, that negative, that causes your y values to turn into negative values. So I plot at 0, 0, and then without even looking at the chart, I know I'm going to go over 1 and down 1 because x is 1 and the square root of 1 is 1, but it had a negative. I'm going to go over 4. 1, 2, 3, 4, down 2. I'm going to go over 9 and down 3 because remember, the y values are the square root of your x values, and then you can just sketch graph it. Okay, now, a shortcut that I'm going to have you guys do today is we're actually going to use the domain and the range to graph without using a chart. So I'm going to do I'm going to call this the initial point. And that's what you're going to try to find today is the initial point. Because once we use that, we're going to be able to use transformations to graph. And this is how you find the initial point. To find the x value of the initial point, find the domain. Set that greater than or equal to 0 and solve. Okay, so that means all of our x values have to be greater than or equal to 0. So to find that initial point, we know that we're going to go at 3 on the x. The y point is super easy to find. It's whatever's added back here. I don't see anything there, so you could visualize a plus 0. So that's 3 zeros, so that's our starting point. 1, 2, 3. Now, without a chart, I'm going to graph this because we're going to use the repetitive shape of a square root function. Now, I got to remember that it's going down. It's a reflection. It's going down, and it's always over 1, down 1, over 2, 1, 2, 3, 4, and down 2. You could go over 9, but you're going to be pretty far off the graph. So as long as you get that curve going, visualize that 3 off the graph. And that's a really good graph right there. So remember, every time you move over, that's your x value. The square root of x is, or square root of 1 is 1, the square root of 4 is 2, and the square root of 9 is 3. And there's your graph without much work. So let's go to this back side. The front side did not say to compare, but it did say to give the domain and the range. So remember, domain is what's under the radical, greater than or equal to 0. The range is kind of easier to find from the graph, but you got to remember it's y. It's going down, so that means it's less than or equal to, and the highest y value is 0. So our domain for this one, remember, we got it from right here. So the domain is x is greater than or equal to 0. And the range, just like over there, the highest y value is 0. So it's y is less than or equal to 0. Okay, now, when you have stuff going on the outside, what we have to remember, this is going to cause a vertical translation, but we really don't have to worry about that too much. We are supposed to compare it, which makes sense. Now, this does say graph the parent function. The parent function is 0, 0, 1, 1, 4, 2, and 9, 3. Those are our perfect square x's, and their square roots are the 1, the 2, and the 3. Now, this one is going to cause that vertical translation. But if we go to find the initial point, okay, we go to find the initial point. The initial point comes from finding the domain. So since the domain is from 0 on, the initial point x is 2. The number outside is the y value of your initial point. So 0, 2 is up here. But notice there's nothing outside of that square root of x reflecting it. So it's the basic shape of this parent function. Over 1, up 1, over 4. 1, 2, 3, 4, and up 2, over 9, and up 3. So from this point, go over 9 and up 1, 2, 3. Okay? So it's from here. So then we're going to sketch that in, and it goes just like that. Oops, I went up just a little too high. I went up a little too high for that one. Okay, so it's over, sorry, from here, 9 and up 3. It's right there. I went up too high. I knew I did because it was only supposed to be going up by 2. Okay, so that's that one. So let's try this next one. Okay, remember, initial point. That's the important point to find, because if we can find that, we can use our transformations better. So our initial point for this one, it comes from taking that inside the radical, setting it greater than or equal to 0, solving for x. And remember that that's our domain value. Now this side of the worksheet does not ask you to find the domain because we can stop there. So that is the x value of the initial point. Anything added back here is the y value of the initial point, so that's 0. So this one's going to start over here at positive 3. Now, this has a stretch factor. That 2, oops, I'm going to scoot that over, I'm so sorry. That 2 is a stretch. It stretches the y value. So instead of going over 1 up 1, we're going to go over 1 up 2 because the square root of 1 is 2. Over 1 and up 2 is how that one's going to go. Then the final one, this is going to go over 4 and up 8. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. So that's going to stretch it up, and make sure you curve it. The last one will go off the graph. Okay, a couple more here, and then we'll call it done. Okay, we're going to find the initial point. Okay, when we find the initial point, we find the domain. We subtract 1. That's greater than or equal to negative 1. So the initial point is going to start at negative 1. There's nothing added back here, so you're going to start at 0. So we're going to start at negative 1 and 0. Now remember, our shape is stretched by 2. So instead of going over 1 and up 1, we're going to go over and it's going to stretch up by 2. Instead of going 4 and 2, 1, 2, 3, 4, we're going to go up 4. 1, 2, 3, 4. And instead of going 9 and 3, so 1, 2, 3, 4, 5, 6, 7, 8, 9, instead of going up 3, we're going to double it up and we're going to go up 6. And there's your graph without having to use a chart. Okay, one last one here. Remember, find your initial point. We do that by finding the domain, take what's under the radical, set it greater than or equal to 0 and solve. So the initial point is 0. This number added in the back, that's our what? That's going to be our initial point. So this one's going to start at 0 and -3. And then this one's going to go down. Remember, it's got a reflection, but it's just the square root of x. So over 1, down 1, over 4, down 2, over 9, and down 3. So it's going to go that way. Okay, now I forgot to do the translations for this one. I'm missing a translation. The 2 is a stretch. Now, I also forgot to put in the parent function. Sorry about that. And 9, 3. So that's your parent function for that one. Okay, so it has a stretch, but that 3 on the inside, you see how we moved it 3 to the right? That is a horizontal translation, right 3. Okay, now this one right here, the transformations from the parent function, which is 0, 0, 1, 1, 4, 2, and 9, 3, it has a stretch. That's one thing it has. And remember, you went to the left one, so that's a horizontal translation, left 1. This one had a reflection due to the negative, and it had a vertical, see it went down, a vertical shift down 3. Okay, and so here's the parent function. And so you can see how the shape is different. It's flipped, that's your reflection, and that initial point is down. So I hope this helps. Use this video and notes to help you with your homework.